This video is just to show you the breakdown of how the PLC works in the lab. As you can see, as I turn on the main power breaker, the PLC will start up. Initially, when the PLC starts up, it goes through a self-test where it checks the processor as well as the input-output array. Notice as it powers up, it keeps you waiting until it is complete, and then it'll show you what program is loaded in the ESM or on the PLC. So as you can see, now that it's passed, it shows you what revision it is, type of ESM, and then the program loaded. Now I'm going to turn on the remaining power, and what this is this is going to turn on all the peripherals on the PLC trainer, or the boards basically. So the relay that was pushed turns on the power to these guys. On the computer, everything is going to be done through the Studio 5000 program. I'm going to open that up, go to New Project, Logix, and then we're going to select our controller type, the 1756L71, as you also saw on the display. Now this isn't going to be a detailed view on how to run through control Logix, but basically kind of the general overview as to how this interfaces with the PLC. I'm calling this project New Project. That's going to show up later, and I'm going to select the 7-slot chassis because that is what we are working with in the lab. And click Finish. As soon as this loads, it's going to bring up the Studio 5000 environment and bring an organizer up on the left-hand side for us to manage different properties in the program as well as in the PLC. Over here on the left, various things. Right here is the backplane. Now I want you to notice that it says 1756L71 New Project, but it has nothing else under it. We need to change that before we put our first program in. Under the main program, you have access to the main routine, which is going to bring us a blank canvas. This is where all of our symbology goes for creating our programs. Close out of that and look back at the backplane. Again, all I see is the L71, which is the ESM, so I have to create a new module. What's happening here is none of the input-output cards have been created yet, so we have to create those, otherwise we're not going to have the ability to program them in our ladder logic. Again, this video won't be covering the details on how or why I'm selecting the cards that I am, but these are the model numbers that we have in the chassis. Here you see slot 1, and this is actually referencing the PLC chassis. Slot 1 lines up with the DC input, so I have to select the proper type of input card that I have there. There are various different types that can fit inside this Allen Bradley, so I have to make sure to choose the right one. I give it a name, and then I update the version number or revision number, click OK and OK. And then I create it. So I'm not going to go through every card, but I'm going to create 2 input cards. The inputs are in slot 1 and 3, and then 2 output cards, which are in slots 2 and 4. And I will jump to where that is completed as soon as I set the revision, and then we'll show you the outcome. Right here, you see now not only do I have the L71 built, but I have slot 1, slot 2, slot 3, slot 4. That's what I did by building those out by right-clicking on the backplane and clicking New Module. Now I can go back to the main routine and click on the different symbols, XIO, XIC, OTE. You guys are going to learn what all that means. And here's where this made a difference. If I did not set up the slot 1 through slot 4, I would not be able to go in and select that card inside the system and I would not be able to set those data ports or those terminals, those contacts. So if you did miss that step, you wouldn't get too far. You'd probably catch your mistake because you wouldn't be able to do this part here where you're actually putting in the logic and assigning it to a input card and terminal, or output card and terminal. One important thing that I do want to dive into is the online function of the PLC. We're going to do that now. But we got an error. It says failed to communicate with the PLC or with the ESM. We have to tell it to use the USB cable so we can use this program called whoactive, formerly known as RS-Links, to make this connection. So I've pulled up this little app, whoactive RS-Links, and I can look through all the different ways or all the different things that I'm connected to. So this is what's available over the Ethernet, but we need to remember that I'm connected directly to the PLC through a USB cable. So I need to look at that USB cable and open it up. And there it is. There's my 1756 L71, and that corresponds with this connection right here, right on the ESM. Alright, so you can select to go online, but before I do that, I'm going to open up what's under there, show you all the boards. It sees everything, and now I'm going to click and go online. Alright, we get an error that says open project doesn't match the project in the controller. That simply means that the program I just created right here doesn't match what was in there. What's in there is some program called smithing something or other, smithmod SKI3. That's not what I created. I created a project called new project. So what we're going to do is we're going to download, and a download is an operation that pushes the program from the computer onto the PLC to overwrite it. So we're going to overwrite that now so that we can match the two. Once we match the two, then we can go online. As a matter of fact, now you see where it says new project instead of Smith. So the new project has been written to the ESM. Also notice the key that's hanging is connected and set up to remote mode. That's what's allowing us to do a remote program and now flip it to a remote run. So because the PLC is in remote mode, we can control it this way. So we're going to flip the controller to remote run, and now you notice the run LED is green as well. And also on our program we have green lines, which is showing you that the power to the logic is activated. It's more symbolic than anything else. So now when I press PV1, press it 3 times, on the program you see the input flash 3 times. Because we're online, it is registering that information and flashing the output in accordance with the input 3 times. We can see it on the card as well as I push the buttons. The 2 zeros that are flashing on and off are corresponding to the input and output, and PV2, which is a normally closed button, goes off when it's pressed, as you see the 1 turn off. So that's the basic run through the PLC system as far as how to generally get it up and how to communicate with it. Hope you found this video helpful.